Hi there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 6. This is Section 6.4, Day 1. The name of this lesson is Factoring Polynomials. So if you recall in the past, we've learned how to, I think it was Chapter 5, about how to factor quadratic equations and solve for quadratic equations using quadratic formula, using difference of squares, all that kind of stuff. So we're going to be doing kind of the same thing today, except we're going to be factoring and solving for larger degree polynomials, so, cubics, quartics, that kind of thing. Okay, so first thing we need to do is we need to review some factoring techniques to help us with this. So let's get right into it. I guess I better use my pen here. Okay, so first thing we have to remember is GCF. This is the first thing you're going to do no matter what type of polynomial you're given. So GCF is going to be the largest number and the smallest exponent that goes into all the terms. So what's the largest number that goes into 6x cubed and 21x to the fifth? Hopefully you said 3. 3 is the biggest number that goes into both of those numbers. And what's the smallest exponent, x to the third or x to the fifth? It's going to be x to the third. So we pull out the largest number that goes into all the numbers and the smallest exponent that they have in common. All right, and now we're going to divide everything by all the terms by our GCF, which goes in front of the parentheses there, the 3x cubed. So 6x cubed divided by 3x cubed is going to be just 2, because x cubed divided by x cubed is going to cancel out. And then negative 21 divided by 3 is going to be 7, and then x to the fifth divided by x cubed, 5 minus 3 is squared, so we get 7x squared. All right, and there is our GCF, factoring out of GCF. You also want to check inside the parentheses again, too, if you can factor again, but there's nothing we can do inside the parentheses there. 2 and 7x squared are two terms, and they are not a difference of squares, which we'll talk about in a second, we need perfect squares with a subtraction sign between them, so this is as far as you can go, basically. Okay, I also want to refer you to your factor flowchart that I created for you, our Algebra 2 factoring flowchart that we'll be able to use on most of our assignments, and will help you kind of process through the steps for factoring nicely, okay? All right, next thing we have is difference of squares. So difference of squares is going to be two perfect squares with a subtraction sign between them. And the way you factor that is you're going to do the square root of the first perfect square and the square root of the second perfect square, and then you're going to put plus and minus between them. So what's the square root of 25m squared? That is 5m, so we're going to put 5m here and here. And what's the square root of 49? Well, that's going to be 7, so we're going to put 7 here and here. And then all we have to do at the end is put plus and minus between them. And that's how you do difference of squares. It's easy as that. Okay? If you were to FOIL this, if you were to do 5m times 5m and then multiply everything by everything, you would get back to 25m squared minus 49, okay? Perfect square trinomials we've talked about a lot. So what you need is you need a perfect square in the front, which w squared is w. Squared's perfect. That's perfect square. Square root of 121 is 11. And then the middle term needs to be double the two square roots. So 11 times w. What is 11 times w? Well, that's 11w. And double that, is that 22? It is. That's how you check whether it's a perfect square trinomial. So you need perfect squares front and back, and then it needs to be double the two perfect squares multiplied together in the middle. Okay, the way we factor this is we're going to have two parentheses again like this. Actually, no, we're not. We'll do it this way. But basically, all it's going to be is going to be the square root of the first one, square root of the last one, which is 11, and it's going to be the same sign, whatever sign is right here. So it's going to be plus and plus. But I think the shortcut, what I would prefer you to write, instead of doing that, it's just to do w plus 11 quantity squared. This is what I would like you to write for the shortcut. It saves you some time instead of writing w plus 11 times w plus 11. So, okay, let's review smiley face method now. This one's a fun one. I like these. So this one we're going to be doing our parentheses. We're going to need the factors of the first term and the factors of the last term that add to the middle term in the middle here. So we're going to I'm going to draw these. Well, I'm not going to be able to see these there. So. Also, if you need to review some of these factoring things, you can go back to other chapters on Canvas or whatever the learning management system I'm using, and you can figure out what smiley face method was. It's a good review. So, okay, so the square root of x squared is only x and x. So we have x and x. And now we need to use something that's going to multiply to positive 18 and add to negative 11. Well, it's going to add to a negative and multiply to a positive. They both have to be negative, so we know they're both going to be negative. And then what numbers add up to 11 that multiply to 18? Well, that's going to be 9 and 2. And there it is. That's how you multiply. That's how you factor x squared minus 11x plus 18. All right, and then I want you to cross off this x method, super cool method. We don't use super cool method very much. We use smiley face for this as well. This one's just a little bit more complicated version of smiley face method. So this is when the a value is not 1. So see, we had a 1x squared here, and we have a 2x squared down here. So or the fact this is the same kind of process that we're going to have 2x and x basically. We're going to have, it's going to be a little bit more complicated because we have 2x times x instead of just x times x. So we need factors of 21 that are going to add to 17. So what adds to 17? Well, we can do, let's put 3 right here. Let's put 7 right here and see if that works. So 3 times x is 3x. 2x times 7 is 14x. So 3x plus 14x is 17x. So this is the correct factorization. All right. And like I said, the videos on YouTube are available for you at any time to go back and review factoring. It might be a good idea if this was really a hard review for you, but it is important. So, okay, let's go down. Could you go? All right, here we go. Now we're talking about sum of cubes. Sum of cubes and difference of cubes. This is kind of similar to difference of squares. It's kind of it's a pattern, or a perfect square trinomial. It's a pattern, okay? So basically, if you have a sum of 2 cubes, so we have a cubed and b cubed, that's going to factor like this. A plus b times a squared minus ab plus b squared. All right, it's just a pattern that if you were to FOIL this out, let's actually FOIL this out. So down here we have 8x cubed plus 27 equals 2x plus 3 times 4x squared minus 6x plus 9. I'm just going to FOIL this really quick to show you why this works here. But basically, and a cube is going to be, when you take the cube root, you're going to get down to, so the cube root of 8x cubed is 2x. That means that when you multiply 2x times itself 3 times, you get 8x cubed. The cube root of 27 is 3. 3 cubed is 27. Okay, cube means multiply by itself 3 times. But let's go ahead and FOIL this here just to kind of, or not FOIL this, but we're going to distribute this. So I'm going to multiply 2x times 4x squared. That's going to be 8x cubed. Let's do 2x times negative 6x. That's going to be negative 12x cubed, or squared, that is. 2x times positive 9 is 18x. Now we got to do 3 times everything. So we got 3 times 4x squared is 12x squared, positive. 3 times negative 6x is negative 18x. And 3 times 9 is 27. And then if we combine like terms, you can see we have negative 12x squared and positive 12x squared is going to cancel out. And we have 18x and negative 18x. And we're left with the original thing we were talking about there, which is 8x cubed plus 27. So this is how, it's a pattern that if you're factoring a sum of cubes, and the sum means that it adds, a sum of 2 cubes is going to factor like this, the a plus b times a squared minus ab plus b squared. Okay, it's just kind of like difference of squares. Difference of squares was a squared minus b squared equals a plus, oops, that's an x. Would you go? Sorry, it's in the way here. A plus b times a minus b. Okay, that's just a pattern that we know that when we factor, that's how it's going to factor. Same thing down here. 8x cubed plus 27 factors like that. Okay. So let's review in the binomial what this looks like, okay? So some things to write down here. In the binomial, the first term is the cube root, in cube root we put a little 3 over here, of 8x cubed. The second term is the cube root of 27, okay? That they're talking about this 2x plus 3 right here. And the sign is the same. Now what does it mean by the sign is the same? So it was plus here, and it's also plus in that binomial of 2x plus 3. So the cube root of 8x cubed is 2x. The cube root of 27 is 3. And the sign is going to be the same. In the trinomial, which is the second half of this, I can't erase a lot of that. But in the trinomial, we're going to have a squared, let me actually write that, fix that better. a squared. The second term is going to be a times b and opposite sign. And the third term is b squared. Okay? But on your factor flow chart, you will have the pattern. You just need to kind of memorize that pattern, that it's a plus b times a squared minus ab plus b squared. All right? And a similar thing for difference of two cubes is a cubed minus b cubed is going to be this. It's going to be this equals a minus b times a squared plus ab plus b squared. So the difference is these signs are going to match up here. A cubed minus b cubed is going to be a minus b to start, and then you're going to have a plus right here, though. You're going to have a plus right here, though, but for when we have sum of two cubes, it's going to be same signs for the first term and for the original and the binomial, but it's also going to have a subtraction symbol right there, basically, okay? But on your factor flow chart, it will show that what it's talking about, basically, okay? All right, so let's get into some actual problems here. Took kind of a while to get through that, but it's kind of important stuff. Okay, factor each polynomial. So we have y cubed minus 125. Both of those are perfect cubes because if you take the cube root of y to the third, let's do that. Cube root of y to the third, that equals y. That's going to be our a value. The cube root of 125 is 5. 5 cubed is 125. That's our b. And we're gonna go ahead. We're gonna plug into this pattern here. We have a cubed. A cubed minus b cubed equals. It's gonna be a minus b, and then it's gonna be a squared plus ab plus b squared. It's basically the second half here. The a squared plus ab plus b squared is almost like a perfect square trinomial. So the perfect square trinomial is going to be a squared plus 2ab plus b squared. So it's very similar. It's just going to be 1ab for this one, okay? Well, we found our a and our b, which is y and 5. So let's go ahead and do that. So it's going to be y to the third minus 125 equals a minus b. So it's going to be y minus 5 times, and then a squared is y squared plus a times b. Y times 5 is 5y. And then b squared is going to be 25 plus 25. So the biggest thing is, oops, that was my alarm. Better turn that off. All right, apologize for that interruption. This is our final answer right here. If you follow that pattern, this is what, if you factor a perfect sum, this is a difference of cubes, actually. It's a difference of cubes. That's going to be what it's going to factor to. All right. Let's do number 2 now. Number 2 is a little tricky because it looks like it's a sum of cubes, except 16 and 54 are not perfect cubes, okay? So the problem with this is we may have a GCF we need to pull out first, and actually we do have a GCF. So is there a number that goes into 16 and 54? Yeah, we can pull out a 2. And then can we pull out any variables? The answer is no. We have no variables because there's no u over here for the 54. So we're just going to go out, we're going to divide everything by 2. So we're going to have 8 u to the third plus 27. Okay? All right. So now do we have some perfect cubes? We do. We have 8u cubed and 27 are both perfect cubes. So let's take the cube root of both of those because we're going to use a sum of cubes now. So we're going to have cube root of 8u cubed. Oops. Is going to equal 2u. Cube root of 8 is 2. Cube root of u to the third is u. And that's going to equal our a. Then we have the cube root of 27. And 3 times 3 times 3 is 27. So 3 equals our b. And now we're going to keep the 2 in front. Keep the 2 in front along for the ride. And now we're going to use a sum of cubes. So sum of cubes is going to be a plus b goes in front. So 2u plus 3. A plus b, and then it's going to be a squared, so it's going to be 2u squared, which is going to be 4u squared, minus ab, remember it's the opposite of the signs, so Yep, minus, it's going to be minus AB, so minus 2u times 3 is 6u, and then plus, it's always plus at the end, it's going to be b squared, which is 9. And this is how it factors. So you might have a GCF floating around in the front of the parentheses, and that's okay. All right, and that's how you do sum and difference of cubes. Okay. Let's talk about factoring by grouping now. Let's change up our pen color finally. Let's use blue. All right. It says grouping. We used to group. This is used to group when you have 4 terms. When you have 4 terms. Okay. So I'm going to kind of ignore the stuff on the side here. And we're just going to kind of talk it through a little bit on the end here. Okay. So the way this is going to work, we have x cubed plus 2x squared plus 9x plus 18. We have 4 terms here. This is a polynomial with 4 terms. So the first thing we're going to do is we're going to split it into 2 parts. So I'm going to draw a line like this. That was bad. I'm going to draw a line like this, okay, and split it between the first 2 terms and the last 2 terms. Next thing I want to check is I want to check the signs, okay? So what are the signs of x cubed and 2x squared? Well, those are both positive. I'm going to put the positives above here just to kind of help us with this. Because if they're not matching up, and then what are the signs of the 9x and the 18? Those are also positive. So these signs match up. We got positive and positive and positive and positive. But if they did not match up, if they were positive and negative, we would have to pull out a negative and do something a little bit different, which we'll talk about for the next problem. But for now, we're good. So now what we're going to do is we're going to pull out a GCF twice. We're going to pull out GCF out of the first 2 terms and a GCF out of the second 2 terms. Okay? So what's the biggest number that goes into x cubed and 2x squared? Well, there's no number because it's a 1x cubed. Is there a small exponent we can pull out of there? Well, we can pull out an x squared, right? X squared is the smallest exponent between x cubed and x squared. So we can pull out x squared. And then divide by x squared, x cubed divided by x squared is going to be x. And then 2x squared divided by x squared is going to be 2. Okay? Now, because the signs are the same, we're going to put a plus here. If the signs were not the same, you'd put a minus there. Okay? But because they're all matching, you're going to put a plus here. Now we're going to pull out a GCF out of the second 2 terms. Is there a GCF that goes into 9x and 18? Well, we can pull out a 9, and there's no x in the other terms, so we're going to pull out 9, and then we're going to have x plus 2. Okay. And now we're going to pull out a GCF again, but the GCF again for this one is going to be this entire expression, x plus 2. We're going to factor out x plus 2 in front, and then we're going to put the rest of whatever's left over in the other parentheses. We have x squared plus 9. Okay? And that's how you do factoring by grouping. This should be a bit of a review because we covered it a little bit earlier, but I just wanted to see how you did. Okay, see if you can do examples 1 and 2 on your own. Number 2 might be a little tricky, but do the best you can. We'll go over it in a second. All right, number 1. So we have x cubed plus 3x squared plus 10x plus 30. Let's split it first. Check the signs. These are both positive. These are both positive. So we can just pull out a GCF now. So we got an x squared times x plus 3. That's our GCF. When we divide, we get that. Plus, our GCF for the second 2 terms is 10. And there's no x we can pull out of here, so we're going to do x plus 3. If you are doing grouping correctly, I should have mentioned that up here. This x plus 2 should match up, and these x plus 3 should match up. So it means we're doing it correctly because they match up. They're doing well. Then we pull out our x plus 3s. And x squared plus 10 is left over. And this is our factored form. And if you were to FOIL that, you'd get back to the original problem, which is the x cubed plus 3x squared plus 10x plus 30. All right, let's do a harder one now. All right, we have x squared y squared minus 3x squared minus 4y squared plus 12. Let's split it again, split it right here. Check the signs. This is a positive and a negative this time. And over here, we have a negative and a positive. So we're actually going to have to do something a little bit different here because these signs don't match up exactly. Now, what can we pull out of the first 2 terms and the first 2 terms here? Well, we can pull out an x squared. That's our GCF. And what's left is y squared minus 3. And then we can pull out, now, right here, we usually put a plus after this, but because the signs don't match up, we're going to pull out a negative here. Pull out a negative. That's going to change the signs. And we can pull out a 4. We can pull out a 4 out of the second 2. That's our GCF. Then we have y squared minus 3. All right, now we pull our y squared minus 3 out in front. We have x squared minus 4. But you also want to check at the end. We're actually not done now because we have, I should have mentioned that earlier, but it's okay. We also have a difference of squares now in the x squared minus 4, so we can factor this a little bit more. So we're going to have y squared minus 3, and then we're going to have x plus 2 times x minus 2. That's going to factor x squared minus 4. Oops. X squared plus 2, x minus 2. And this is factored form now. Okay? All right. We have one more type of example, and then we're going to pause and we'll do day 2 a little bit later. Okay, quadratic form, we're going to rewrite as squared terms. Rewrite as squared terms. Or substitute to make squared terms, okay? So, the way we do this, let's talk about the first example, which is factor each polynomial. We have 49x to the 6 minus 121. So, if we had 49x squared minus 121, we would know how to factor that, right? That would be a difference of squares, which equals 7x plus 11 times 7x minus 11. Okay, this one's a similar thing because we have an even exponent in the 49x to the 6th. So what I'd like you to do is divide that in half. You're going to divide the power in half because, and I'll show you why in a second here, but this first term can be rewritten as square root of 49 is 7. Square root of x to the 6th is x to the 3rd. So it's going to be 7x cubed to the 2nd minus, and then we have 11 to the 2nd power, okay? Because if you were to like redistribute that 2 to both of these, you would get 49x to the 6th. So basically, when you're trying to take the square root of an even exponent, you divide it in half. That's kind of how you do it. So now we can actually write this as a difference of squares, even though it's not really like a difference of squares. It's a difference of, well, it's a difference of squares. It's just got some weird, big, kind of answers. So we're going to have 7x cubed right here and here. We're going to have 11 here and here. And we're going to have plus and minus. And that's going to be how we factor it. So it's just a variation of difference of squares like we did over here. Except now we have a x to the 6, which we need to kind of treat a little bit differently. Okay, this is our final answer right here. One more example. Now we have number 2. We have x to the 4th minus 7x squared minus 18. This looks similar to a smiley face method problem. So we're going to do a smiley face method problem, but we're going to be doing it a little bit differently. So instead of putting x here and here, we're going to put x squared here and here. We put the square root of x to the 4th, divide it in half, and that's what we're going to be what we're going to do. All right, now we need factors of negative 18 that are going to add a negative 7. Well, that's going to be negative 9 and positive 2. Negative 9 and positive 2, if you multiply these, you're going to get negative 9x squared. Multiply these, you're going to get 2x squared, which equals 7x squared. This is going to factor, now we have, so we have x squared minus 9 times x squared plus 2. And now we can actually factor this first one. We have a difference of squares again. You also want to check if you can factor some more. The x squared minus 9 is going to be x plus 3, a difference of squares, times x minus 3. And then we're going to have x squared plus 2 is going to come along for the ride. And this is our final answer. Okay, I think we're going to stop there for today. Thank you for watching. Have a great day, and we will talk soon.